This is the podcast for polynomial functions of a higher degree. We're going to start with something that should be review. Let's say you had the parent function y equals x to the fourth. Without even graphing or knowing what the shape looks like, you should be able to tell what certain shifts will happen to each function from previous units. So let's take a look at A right here. Y equals x plus 3 to the fourth power. How does the plus 3 in the parentheses shift the graph? Well, plus 3 inside the parentheses would be left 3. Let's try that again. Left 3. X to the fourth minus 3. Since the minus 3 is on the outside, that would be down 3. The 4 is positive. It's on the outside, so that's up 4. And if you think back to quadratics, if you had a negative in front of the x squared, that turned your parabola upside down. And it does the same thing for the x to the 4. So it would turn it upside down. The 0.5 would make it fatter or wider. The minus 1 inside the parentheses would make it move or shift left 1. The minus 5 would make it narrower or skinnier. The x plus 3 would make it shift left 3. So I should change this. This is not left 1. This would be right 1. Whoops, let's redo that. So here the x minus 1 in parentheses, right 1, not left 1. And the plus 3 would be left 3. The minus 2 on the outside would be down 2. In class, we do an investigation where we start to look at something called even and odd functions. So we'll break it up while my calculator loads. We'll look at x squared, x to the fourth, x to the sixth, x to the eighth, the even functions, and the odd functions, x to the third, x to the fifth, x to the seventh, and x, which are odd functions. And this will load. And we'll type them in and see how even functions look and how odd functions look. Now you should already know what x squared looks like, so let me load that. Alright, so I'm going to open a new graph page. Let's do a new graph. So let's do x squared first. Let's look at even functions first. So x squared here's our parabola with the vertex at 0, 0. If we hit tab and type in x to the fourth, we can see that it also looks parabolic in nature, but it looks like the slope is steeper, and it looks like it flattens out near the vertex. Let's try x to the sixth power. And again, you can see it is narrower, flattens out more. If we zoom in, you can see how it flattens out more, but then becomes more narrow. All right, let's look at odd functions then. I'm going to erase these. Odd functions would be like x to the third. Well, here's x, y equals x. Let's do x to the third. Let's do x to the fifth. And again, you can see that near the x-axis it starts to flatten out, and it does become steeper as we go to the left and to the right. And that is called end behavior. We'll take a look at that too. Let's do one more x to the seventh. Again, if you're making predictions, it will probably flatten out near 0, but then become steeper as you go to the left and right. And it does. So those are odd functions. Now we're going to fill out this chart right here. So it says, what is the highest exponent, even or odd? So these ones were even. As the x values get closer to negative infinity, Are the y values positive or negative? So this is left-hand and right-hand behavior. Here's an even function right here. As the x values get closer to negative infinity, what that means is the left-hand behavior, as you're going to the left here, our values are increasing or positive. As we go to positive infinity to the right-hand side, is our graph increasing or decreasing? It's going up, it's positive. And then as the exponent gets larger, what happens? The x value is close to 0, it flattens out. Now when it's odd, looks something like this. And again, the left-hand behavior, as we go to the left, our values go down, but as we go to the right, our values go up or positive. So the lead coefficient test, the graph of any polynomial, eventually rises or falls depending on the lead coefficient and the degree. Of the function. Let's fill out a table. If your highest exponent is even, I call those the field goal function because they look like parabolas. They go up. They start up and they end up. They end in the same direction. If the lead coefficient is positive, the left-hand behavior increases, the right-hand behavior increases. But if the lead coefficient is negative, it flips it upside down, and the left-hand behavior is decreasing, and so is the right-hand behavior. Now, if it's an odd function and the lead coefficient is positive, I call it the bendy straw. That's my fifth hour calls it. Think about drinking up the straw. So the left-hand behavior is decreasing, but the right-hand behavior is increasing. So drink up the straw. If it's negative, it flips. So think about like backwash or spitting out your fluid. So it's leaving your straw if the lead coefficient is negative, which means we start up or increasing on the left-hand side, and it decreases. Okay, so I want to go from the notes actually to something else. So I think is it this way? All right, a few things. Degree is the highest power. The lead coefficient is the number in front of the exponent with the highest power. So two examples. The degree of this one in blue is 5 because 5 is the highest power. The lead coefficient is 3. So if we talk about end behavior, this will be a bendy straw. We know that it will start low and it will somehow end high. The middle might look a little bit different, but it starts low and it ends high. Think about drinking up the straw because the 3 is positive. Now if we look at the next one, the degree is 3. Again, another odd function, so another bendy straw function. The lead coefficient is -1. So this one is the opposite bendy straw. In other words, the liquid starts up, but then it goes or leaves the straw or goes out of the straw. And then let's go to... Now again, this is not in your notes. We went over it the next day. Even functions, think field goal functions. They end the same way. So either a field goal up or field goal down. To tell the difference, if it's an even function, if the highest power is even, it's going to be a field goal up, which means some things might happen in the middle, but our end behavior is the same, positive, increasing, and increasing. If it's an even function, so even but negative, so like negative x to the 4th, it will start decreasing, something might happen in the middle, but then it's going to end decreasing. So think field goal down if the lead coefficient is negative. And again, we looked at the odd functions, bendy straw functions. If the lead coefficient is positive, it starts low, ends high. And if the lead coefficient is negative, it's going to start up high, increasing, but then end up decreasing. Or think about liquids leaving the straw. So again, here it is, positive and negative lead coefficients, even and odd. So even are the field goal functions. This one has a 6 right here, so it's even. The lead coefficient is 5, so we know that the end behavior, both of the ends will be increasing. So our graph might look something like this, where it's field goal up. Here's an example of field goal down, so it starts decreasing, something's happened, and then it ends up decreasing. For odd functions, again, this is bendy straw up, and this will be bendy straw down, so starting up and then eventually going down. So you have to know the end behavior, the left-hand and right-hand behavior. So here's more examples. This is an odd function. It's a bendy straw. It starts up, goes down. So the left-hand behavior is increasing. The right-hand behavior is decreasing. This is an even function, so we look at the end behavior. The left-hand side is increasing. The right-hand side is decreasing. So there's left-hand and right-hand behavior. Here's the last important point, and that is the number of turning points can indicate the degree of the function. We know this is a parabola. It has one turning point, and we know that would be an x squared function. So if there's one turning point, it is degree 2. If there's 3 turning points, it's degree 4. And looking at the end behavior, it ends down, so we know there would be a negative lead coefficient. We don't know the exact equation, but you can give me the degree 4, and you can give me the lead coefficient would be negative. The last function, there's 1, 2, 3, 4 turning points. So it's degree 5. Again, you can tell it's a bendy straw, and it's bendy straw starting down, going up, so this would be a positive lead coefficient. You're drinking up the straw. So those are main ideas for your assignment. For your assignment, let me pull it up. I wonder if I have it here. I want you to skip a few problems. I don't want you to do all of them on the assignment, so let me pull it up. Okay, so this is day 2. So you should be able to do the matching. You should be able to tell the degree and the lead coefficient and match it up, so that's fine. Transformations are fine. What we haven't gone over is number 4 and 5. Write a polynomial in factored form that has these zeros. You should know the factors are the opposite of the zeros. So the opposite of negative 4, that 0 would be plus 4. If you have 0, it's x, and the opposite of 5 is negative 5. So here's an equation in factored form. Now if it's 4th degree, but we have 3 zeros, here's what it might look like. X plus 5, x minus 1, x minus 2, but notice there's just 3 x's, that's x to the 3rd degree. So you have to, one of these zeros is going to be a repeated root. So you either put a squared for the first function, or you could do it for the second, not function, but 0, or factor, or the 3rd factor. You could put a squared in that, then it would make it 4th degree. Now on the back side, skip the word problems, 9 and 10 you don't need to do. And then for 6, 7, and 8, all I want you to do is the first 2 parts. Describe the end behavior and state the maximum number of turning points.